Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about the summary of the Chapter 8 and the Chapter 8 entitled Subnetting IP Networks. Subnetting is the strategy used to partition a single physical network into more than one smaller logical subnetworks or the subnet. It says here that the subnet is used to it's like to divide the physical networks into the smaller logical subnetworks. An IP address includes a network segment and a host segment. Subnetting helps to reduce the network traffic and conceals network connect complexity. Subnetting works by applying the concept of extended network addresses to individual computer and another network device address. But because this is a Class C network, the default subnet mask of 255.255.255.0 allows all computers on the network to be peers to send the message directly to each other by default. So it uses the subnet mask of 255.255.255.0. A subnet mask is used to divide an IP address into two parts. One part identifies the host or the computer. It the the IP address is used to divide the IP address into two. So the part one is used to identify the host or the computer, and the other one is part is to identify the network to which it belongs. To better understand how IP addresses and subnet masks work, look at an IP or the Internet Protocol address and see how it is organized. The main purpose of subnetting is to help relieve network congestion. It says here that the main purpose of subnetting is to help to relieve the network congestion. To prevent the congestion, we are doing the subnetting. Congestion used to a bigger problem that is it is today because it was more common for networks to use hubs than switches. The network is um, it uses or use hubs than switches. When nodes on a network are connected through a hub, the entire network acts as a single collision domain. Registered ports. The numbers 102 to 49,151 are assigned by IANA or the IANA. Requesting entity to use with specific processes or applications. These processes are primarily individual applications that a user has chosen to install, rather than common applications that would receive a well-known port number. For example, Cisco has registered port 1985 for its Hot Standby Routing Protocol or the HSRP process. In a segment, the transport layer header will include the source and destination process or port numbers. Destination and source physical addressing is included in the frame header. Destination and source logical addressing is included in the network header. Application data are encoded in the upper layers of the protocol stack. A socket is a combination of source IP address and source port of or the destination IP address and the destination port. So, uh, the socket is a combination of IP address and the source port. It also a destination IP address and the destination port number. Each application process running on the server is configured to use a port number either by default or manually by a system administrator. So the system administrator is the one to configure the use of port number, either it is by default or manually. An individual server cannot have two services assigned to the same port number within the same transport layer services. So it says here that the individual server cannot have the two services at the same time. So a host running a web server application and a file transfer application cannot have both configured to use the same server port. There can be many ports open simultaneously on a server, one for each active server application. Window is the number of bytes that the sender will send prior to expecting an acknowledgement from the destination device. So, uh, the window is the number of sender will send prior to the expecting an acknowledgement from the destination device. So, the initial window is agreed upon during the session startup via the three-way handshake between the source and the destination. So, uh, it has agreement during the session of startup via three-way handshake. Uh, that agreements between the source and destination. It is determined by how much data the destination device of a TCP session is able to accept and process at one time. If the source determines that TCP segments are either not being acknowledged or not acknowledged in a timely manner, then it can reduce the number of bytes it sends before receiving an acknowledgement. Notice that it is the source that is reducing the number of unacknowledged bytes it sends. This does not involve changing the window size in the segment header. So I have here the question. A PC is downloading a large file from a server. The TCP window is 1000 bytes. The server is sending the file using 100 byte segments. How many segments will the server send before it requires an acknowledgement from the PC? So here is the answer. With, with the windows of 1000 bytes, the destination host accepts segments until all 1000 bytes of data have been received. Then the destination host sends an acknowledgement. So the question here is how many segments? Uh, so it will, the answer for that is until all 1000 bytes of data have been received. Then another one is a host device is receiving live streaming video. How does the device account for video data that is lost during transmission? So here is the answer. So it has a long answer. When TCP is used in the transport protocol, data must be received in a specific sequence or all data must be fully received in order for it to be used. TCP will use sequence numbers, acknowledgements, and retransmission to accomplish this. However, when UDP is used as the transport protocol, data that arrives out of order or with missing segments may cause a momentary disruption. But the destination device may still be able to use the data that has received. This technology results in the least amount of network delay by providing minimal reliability. Since live streaming video applications use UDP as the transport protocol, the receiver will continue showing the video although there may be a slight delay or reduction in quality. So this is the third question. Network congestion has resulted in the source learning of the loss of the TCP segments that were sent on the destination. What is one way that TCP protocol addresses this? If the source determines that the TCP segments are either not being acknowledged or are not acknowledged in the timely manner, then it can reduce the number of bytes it sends before receiving an acknowledgement. This does not involve changing the window in the segment header. The source does not decrease the window that is sent in the segment header. The window in the segment header is adjusted by the destination host when it is receiving data faster it can faster than it can process it. Not when network congestion is encountered. So this is the again the question. Which action is performed by a client when establishing communication with a server via the use of UDP at the transport layer? Because a session does not have to be established for UDP, the client selects a random source port to begin a connection. The random port number selected is inserted to the source port field of the UDP header. Which two services or protocols use the referred UDP protocol for fast transmission and low overhead? Both DNS and the VoIP use UDP to provide low overhead services within a network implementation. So thank you. That's all for this video. Thank you for watching.